Hello and welcome everybody to today's lecture about distance protection. And today I would like to focus with you on the Earth return path matching factor. A little bit complicated word, but it is highly useful. So let's look why we can use this Earth return path matching factor. What is the purpose of a distance relay? The purpose is to determine the distance between the location of the relay, R, and the fault point. And for this, we need the so-called line impedance, from which we can easily determine where the fault is geographically. So for the consideration, we start with a healthy network with a symmetrical load. That means we have a phase voltage, we have the line impedance, the phase current, and the three-phase load. And since all these are fully symmetrical, it turns out that the so-called line impedance is identical to the positive sequence impedance, or as some other people say, it's the power flow impedance. This is very usual and very common to all electrical engineers. So now we reduce the impedance value of the load to 0, and then we have a three-phase short circuit. And again, the three-phase short circuit is represented by the positive sequence impedance. So this is familiar to everybody, but now we change the three-phase fault into a single-phase to ground fault. So the current comes from the left through the line, goes down to ground, and returns through the ground path. And the distance relay measures the phase to ground voltage and the current. And from this, it would like to conclude what is the impedance value of the fault. So apparently, the whole loop is made up of the positive sequence impedance. Some people say it's the impedance above ground, plus something. And this something is the mass impedance, which is, as we generally say, underground. By the way, in cable network, it is the sheath impedance. Okay, so now we have this together, and the relation between the mass impedance and the positive sequence impedance, the line impedance, is constant, so we can put the whole loop impedance into these parts. So to find out the positive sequence impedance, which we would like to have, we must know the Earth return path matching factor by measuring the positive sequence and the zero sequence impedance. So let's look first at the application. So the application is we want to have the positive sequence impedance, which is the line impedance from the relay to the fault, but we measure the loop impedance. And the loop impedance then can be calculated back by applying this formula when we neglect the load current. And if we take substantial load current into account, then this formula is slightly modified. That means we have to include the line current and multiplied by this earth path impedance matching factor to multiply it with the sum of the line currents. So how can this factor be determined? We have seen this formula, and now we need two components, the so-called zero sequence impedance and the positive sequence impedance. Let's start with the positive sequence impedance first. The positive sequence impedance is the normal load flow impedance, and this in this case is determined by short circuiting the line at the end, then applying a symmetrical voltage at the beginning, and just determining the quotient between the voltage and the current, and this is a positive line impedance. So the zero sequence impedance is determined in a similar way, but not the same. In this case, we short circuit the line at the end, then we short circuit the line at the beginning and apply single phase voltage source to it. So that means we generate three identical load currents or fault currents through this loop, and the quotient of these, voltage divided by one of these line currents, is the zero sequence impedance. So from this we can determine the Earth return path matching factor by dividing 0 divided by positive sequence minus 1 and so on. And then we can determine from this the relay to fault impedance, which is the familiar line impedance. And this is used for the relay output, which triggers the relay and determines the protection behavior. So this was today's lecture about distance protection with a focus on the Earth return path matching factor. I thank you very much.